and operation people, so people that will go and deploy and operate those APIs in productions. And well, you see there is a problem. How do I write a memory dump, and how do I troubleshoot it? So if you have any questions, you can keep them to yourself. No, I'm just joking. So you can feel free to interrupt me at any time if there is something you don't understand, or if you want more details. But before we get into WinDbg itself, well, we need a memory dump, because you need something to start with. And the tool I recommend to write a memory dump pretty much everywhere is pubdump. So that is part of the sysinternals suite, which is free. And the main reason I recommend this tool is because it's already present in Azure App Services. So if you go, when you have a web app and you go in the UI, the advanced tools that will go to the Kudu console, and then you go to PowerShell. If you go to d/devtools, it has a couple of things, including sysinternals in there, so you can just go and invoke pubdump from there. So that's the command you will type. So pubdump 64 for 64-bit.exe. So the first two switches, -r and -a, so those one is the ones that you normally do when you are on the hardware yourself, because what it does is that it will take, or it will do like some kind of a clone of the process, and it will avoid an outage. So it means at one point in time, pubdump will just capture the whole memory, the whole heap, and like this, IIS will continue to serve requests during this time. So it's quite important if you're serving a high traffic production website, because you want to avoid obviously to be down for the few seconds that the dump will require. The problem is you cannot do this in Azure App Services, because the user that Microsoft is giving us doesn't have the permission to take a snapshot. So you cannot use -r and -a. This means that you'll have an outage, which depends on the size of your heap, but roughly 4 to 5 seconds. That's to be expected. So -ma, and this one is very important, and that's how to take a full dump. So that doesn't mean everything that's in memory. That's just a full dump of your process. And that will capture, obviously, if it's C#, well, the heap and the stack and all this kind of stuff, because if you don't have this, well, there's not much you can do, to be honest, when you analyze the memory dump. And of course, at the end, the process ID. You can also use the name, and the problem is, of course, if you have multiple IIS instances running, well, that won't help. Something that's quite important, especially on Azure, is to accept the end-user license agreement. So that's the one at the bottom there. Because if you don't, all you get, it's a prompt, basically asking you to accept the end-user license agreement, and no dump will be written. So that's always a surprise the first time. The second reason I recommend pubdump is because it will handle automatically the bitness of your process. So it doesn't matter if you're running your app pool is 32-bit or 64-bit, pubdump will automatically capture and write the proper memory dump. Because on Kudu, also if you're familiar with it, there is this tab which is like Process Explorer, and you can write a memory dump from there. The problem is the operating system is always 64-bit now on Azure, and if you run your process in 32-bit, it will capture a 64-bit memory dump of your process, which is not as easy to analyze in WinDbg. So that's why also I recommend pubdump. So, but once you're done with the memory dump, this is actually where you're getting started, because it is very likely that you will not analyze this memory dump, in Kudu in PowerShell, or using NTBSD and just issuing command. It's probably better to have some kind of UI and be able, to be on your desktop and have some time and be relaxed. And this is where most of the people get stuck. Okay. And that's the point, that this is what is very poorly explained, and is how to ensure that once you copy this memory dump to your machine, you'll be able to load it, and you'll be able to issue commands that will yield output that you expect. So I've got 3 slides that are coming. They all have a star in the top left corner, and those 3 slides, if you follow basically those slides, that is guarantee that you'll be able to issue commands against a dump, and you'll get what you expect. You might not find or troubleshoot what the issue is, but at least you'll be able to issue commands, which I think is the main frustration that people have with WinDbg. And the first thing is we need to talk about the runtime. And as you know, C# is managed. It's a managed language. And the problem is WinDbg is, as his name says, is the Windows debugger. WinDbg knows about native memory and the abstractions that Windows, the operating system, provides to it. So this means that if you take a memory dump and just load it as is in WinDbg, well, you will see, of course, things in there, but you have no idea about what those objects are because, well, if you look at the heap, objects have layouts, they have headers, they have metadata associated with them. WinDbg has no knowledge whatsoever about them. And this is why you need two key components when you want to analyze a dump. So the first one is the DAC. So it's the data access component, and this one ships with the CLR. And it's got this lovely name right now. It's called MSCORDACWKS.DLL. So Microsoft, again, has demonstrated that they're pretty good at naming things. And what this does is that this knows what the CLR does. So this knows the object layout. How a string is represented in memory when it's been allocated by a program. It knows that, well, when the garbage collector is running, it will move your objects. It knows that your heaps might get compacted. It knows about app domains, which is something that is a .NET full framework version, and WinDbg knows nothing about. But this is extremely low level. This is what the CLR does. And of course, as a human, you don't want to say, hey, please, give me the object at this address and give me metadata and give me this. It will take you days to look at what's inside a memory dump. And this is why Microsoft created the Son of Strike extension, because WinDbg support an extension model. So you just can, well, you probably won't, but some people do. They create extensions for WinDbg. So you just need to respect the contract, and then you can load them at runtime. Once you've loaded your memory dump, you can just say, hey, load this DLL because it provides some commands. And it's exactly what SOS does. So commands can be, oh, tell me what are the managed threads in my application, or tell me what's inside the heap, tell me the biggest object in a heap, tell me what this exception looks like. So all these kind of things. And for a human, it's a lot nicer already. So this one is called SOS.DLL, and as I said, the other one is MSCORDACWKS.DLL, and they are both present in the .NET framework folder on your machine. And the problem is, you need to get the right ones, because first, as I said before, your process might be 32 or 64 bits. And if you grab the wrong one, well, that won't work, quite obviously. And the second point is, this is based on the .NET framework version, or rather the CLR version. So nowadays, it's very likely that you're targeting at least CLR4. So you just go to the highest number in there and grab it. And in case of that, just grab all of them. Just do a where.exe command and you'll see all the SOS.DLL that are present in the target machine and just copy them, all of them locally. Because in WinDbg, when you issue commands and things go right, you don't have outputs, but when things go wrong, you get error messages. So quite often you just say, okay, that didn't work, I'll just grab the other file. So that was the first important part about getting those two DLL out of the target server. So now we need to talk about symbols, which people refer to as PDBs. That's what happens when you go, by default at least, when you go and build inside Visual Studio or Roslyn, and you get those DLLs, and then there is another file with the same name just under it. Because as I say again, WinDbg has no knowledge of C#. And so the goal of symbols, so first when you build, let's take Visual Studio and a default C# application. So you go and build, you use MS-build, which will invoke Roslyn under the hood, and that will compile your C# into IL, and that's your DLL. And then at runtime, the CLR, will take this DLL and will JIT it. So when it thinks that a method will be executed, it will just turn and compile down this IL into machine code or bytecode. So the CLR knows, obviously, how to go from bytecode or IL code, but it doesn't know the other way. So to go all the way to your C#. But when you're looking at WinDbg and stack traces, you don't want to be reading IL, obviously, because that's not what you wrote. So, and that's a lot harder to read than C#. And this is why we have symbols. So symbols allow us to translate one to the other. And when you use a debugger, it will look and we'll have offsets, basically, of saying, oh, this instruction is mapping to this C# instruction, so that then we can have those nice stack traces that tell you, oh, in this file, at this line, there was this method being called. Now, this is why this is critical that you version your DLLs. because if you've got a production issue, or a bug, or a crash, and you don't know, well, obviously, when or how this was built, and which, commit was it, or which version it was, well, it's a bit hard to go back and say, well, I have to look at IL basically, or I'll try to decompile myself. So you don't have to, to use strong versioning or these kind of things. You can just use the assembly information version attribute, because this one has less constraints. So you can put whatever you want in there. Just you need to be able from this to say, oh, I know this was built on this build, and this is this commit. So like this, you can walk back and say, fine, so you can then go and potentially even look at the source code on your machine once you get stack traces. The second piece of information that's quite critical to set, in Visual Studio, is the debugging information. So you go to, you right-click on the project, so Properties, Build, Advanced. You want to make sure that debugging information is set to full or PDB only. So as of .NET Framework 2.0 and more, that means the same thing. There's no differences between the two, but you certainly don't want to set none, because if you set none, well, no PDBs will be generated. So this means that you're out of luck there. So I don't know if some of you are using ASP.NET Core or .NET Core and deploying, on non-Windows platform, but if you are, you don't want to be doing this, because that's not portable, that's a Windows format only. So you want to use portable, and the problem is, as of today, WinDbg does not support the portable format. So that's a bit harder when you deploy to Linux. And of course, the third point is that when you, let's say on your CI/CD, when you build, well, you want to publish the symbols to somewhere you can download them later, because, your API might stay in production for a few days, a few weeks, a few months, depending how often you release. So you want to make sure that they are preserved, so that should the need arise at some point in time, they are there, and you've got a proper build version, and you can walk back. So you can extract DLLs from a memory dump via the save module command, but why should you if you can just archive them and have them, just download them when you need them. And finally, whoops, sorry. So debugging without symbols also is not fun. I can tell you, because all you'll see is basically machine code and offsets. So you just see offset, 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 and just like, that's great. And then you can go and decompile, so those lines. But it's a lot faster if you have access to the symbols. So finally, and this is where we get to see very soon the beautiful UI of WinDbg. The third step, this is to configure WinDbg. So there's a one-time configuration. So see, we're talking again about the symbols. And this is to point WinDbg to where it can look for those PDBs. So in this case, we've got two categories. We've got ours, so the one from our company. So I tend to always put them into symbols local. So this, each time you investigate something, you just put them in there. And then you also point to the public symbols from Microsoft, so that when you look at a stack trace and they say that you're running ASP.NET, you'll also have all the nice stack trace from when you instantiate your controllers, the filters, and all the things in between. And the source, so that's a bit less useful, but let's say you can configure these too. And so if it's a console application or Windows service, so you can put the exe in the source. So that also help WinDbg to generate nicer stack traces and look at them. And when you analyze a dump, all you have to do is retrieve the PDBs and copy them into your local folder. So you can do this before or after. If you do them, once, you can just reload your symbol, so .reload. But what's quite interesting though is, and I think rightly so, Microsoft have been criticized for quite some time for not investing into WinDbg. It's a tool that is a bit abstract. It doesn't have the nicest UI to get started with. So last year they released a preview version, which is available via the store. So if you have Windows 10 anniversary update and above, you can download this. So this is what I'll be running later. And their goal is to make it easier to start, so to get started. So it's got the the ribbon UI like same than Office and Word and this kind of stuff. So it's got nice buttons you can click. And the main difference is in terms of symbols, because that's a bit tricky. So when you run let's say the classic version of WinDbg, there's this notion of workspace, which, well, you don't really need to know about, but it's just the first time you open WinDbg, you go and configure the symbols, and then you save your workspace and you close it, and like this, it will be persisted. And it will work nicely for the other times. So that's, roughly what it looks like when you use the dark theme in the preview mode. So this is what happens when you open a memory dump. And in here, I wanted to point two critical pieces of information. So the first one, if you don't want to avoid to waste your time, you want to make sure that you can see full memory being written in there, because if you didn't write full memory dump, this means you won't have the heap and the stack trace and these kind of things. And the second point, which you want to make sure that your sim pass, so the symbol search pass, is right. So this one you can fix it at runtime. That's okay. You can fix it once you started. So if you see that's wrong, you can just that sim pass, configure it and reload the symbols. Full memory, you can't fix this. Once you've written the memory dump and the outage is gone and you restarted the server, obviously the heap is gone. So that's why. And if you start to write commands in here, you'll see very quickly that you cannot get anything out of WinDbg. So again, it's quite funny because in the classic version, when you the command to, or rather the UI to open a memory dump is open crash dump in WinDbg. So that doesn't mean that it actually has to be a crash dump. This will open any kind of memory dump. So they did fix this in the preview, and this is just like a nice open memory dump because it makes a lot more sense. So remember when I was talking about those two DLLs? So SOS.DLL and MSCORDACWKS.DLL. So that's how, if you retrieve them from the target operating system, that's how you load them. So first you go and open the memory dump, and you'll see when I get to it, at the bottom of the screen there is this input text where you can type commands. So you just go and .load and the full path to SOS.DLL. And the second one, you just do .core.dll -lp. But in that, you don't put the name of the DLL, you just put the directory path. So once you've done those two, and nothing has been displayed on the screen, it means it worked. If something's displayed, that's an error. Yeah, that's again quite interesting. So SOS, I mentioned a few commands that it has, and it is quite convenient, but the problem is, of course, we don't look at memory dumps on just saying, oh, what is in a heap, or, what is at this address. We look at memory dumps after an outage. So we've got questions such as, well, are there deadlocks in there? Or, how many, maybe, requests was I processing? How many requests are in memories? Or, can I search faster in the heap? And this is why people created extensions. So quite often, there are support engineers from Microsoft. So the first one is very original, is Son of Strike extension. So it wasn't too hard to name. And that's also quite an old one, and it comes with many convenient commands. So I'll be using a few commands of this tonight. And the second one is M for manage extension. So I've got links to those extensions at the end of the presentation. And what extension is, it's just a DLL that you drop into a folder. So in the classic version of WinDbg, you go wherever it's installed, and there's a WinX folder, and you just, paste the DLL in there, and then you can load it. Of course, the WinDbg preview is a store application, so you can't write to the app because it's protected. So you have to load it yourself. You have to say, hey, load this extension. And what's quite important, you have to use the proper bitness the same, because extensions come in 32 and 64 bits because, well, they're not written in C#. This is unmanaged code. Those extensions don't have any documentation at all. So don't go and waste time to go to people's blogs or websites or help stuff. But there's a contract that is enforced, is the .help command, and actually it is a pretty good documentation. So let's say I just issued .load mex. What I can do bang mex.help, and this will list all the commands available in this extension with hyperlinks, and then you can click on the name of a command, and that will display in the WinDbg console, what this command can do, the kind of inputs and outputs. So that's actually the only way you can find what a command does, really. And quite often people ask me, what can you diagnose with WinDbg? And the answer is pretty much everything. So you can diagnose crashes, you can diagnose hangs, memory leaks. So WinDbg can operate both, in a user mode and at kernel level. So you can even, if you want to, troubleshoot drivers and Windows itself. So we won't go into this kind of stuff. So tonight we'll mainly talk about crashes and hangs because they're probably a bit easier to get started. So I'll be typing command, but I've renamed procdump64.exe just to procdump.exe, so it's easier to invoke. And I did it to my path, so I just call it from everywhere. So just don't be surprised if it's not there. So all the applications that I'll be debugging are on my GitHub. So I've got a link, and I've got video walkthrough videos, so you can see if it's a bit too fast or if you have questions, you can just look at the commands I'm typing there. So first one, which is very common. So crashes, that's quite often happens on console apps or workers or Windows services. The app starts and it dies like straight away, and you're just like you say, maybe a config is missing, maybe a DLL is missing, maybe it's trying to reach to something. And the problem is also often you have completely meaningless information to go on with. So if I can everybody read that or yeah, all good? So here I've got a simple application. Wow, but that's beautiful. Okay, maybe that'll be better. So I'll just start it, and so it dies on me, but even worse, So first it's throwing an exception, which is the base type exception. So there's no context at all in here. The message is, you can read it for yourself, so that doesn't help me at all. But I've got a line and a file, and it so happens that I've got the source code on my machine also. Yeah, I'm convenient. Wow, it's like I was prepared. Okay, let me just. Oops. Okay, as soon as I can get this one on the other screen, yeah. Okay, for a moment. It's here, and I'm sure you've all seen this. You've all seen this. Like high-level handler catching any kind of exception. Not capturing an integer variable, mind you, not putting it as an inner variable, and losing every kind of context. So when you rethrow this one, that's gone, basically. And of course, if you look at this, that's a huge and complex service that does some important work. So it could be 10,000 lines, really. So we don't want to look at that because we have no idea what's being thrown. So now the question is, if I were to capture memory dump of this, will WinDbg tell me what actually was the inner exception? And now I have a problem because, of course, I could go and launch this and very quickly, go and procdump and say, oh, capture memory dump, but I'll have to be pretty good at timing. And of course, Mark Pristanovich, which created procdump, sort of that. He made it so we can actually invoke or launch a specified image. So that's what this command is doing. So the first switch, -E, this is a trigger. And what it says is that, hey, please write a memory dump when a condition is met. And in this case, the condition is an handle exception. So we're pretty familiar with first chance versus second chance exception. So what happens is obviously Windows has an error handler that your app will register with when an exception is being thrown as a first chance. So if it's within a try-catch block, you'll be given a chance to handle it in the catch and do something with it. So ignore it if you want, or log it or whatnot. So should you decide not to handle it, or if you don't have a catch block, this will become a second chance exception, which in the case of a console application is terminating. So it will basically, the process will die. And Windows, this is where you get also, the Windows error reporting dialog that say, oh, do you want to debug this application or do you want to report it? So that's exactly what we saw happen. We saw the console application die. So that's why we want to trigger on this switch. So -MA, I hope by now you're familiar, full memory. And -X, this will just instruct procdump to launch crash console.exe and then monitor it for an exception. So as we'll see, you won't have to monitor it for too long. So let me just get my command. But before I forget, because I always do, remember what I told you about the symbols. So we want, so we do want to capture, these are open, of course are open, sorry. Okay. We want to grab the PDB from this, the first thing, to make sure that, okay. So we just get this. Actually, yeah, sorry, I'll just copy, can't really see there. But so I'll just copy it into the sim path which I've configured before. So actually, wait. So yes, you've seen here, so that's C symbols, and I will just say, you know, local, so we just copy it in there. So that was the first step. So we make sure that we'll have something to go on. And now if I go back to the command in here, so that's not the right one. So if I go and capture this command, so that'll be pretty much the same one, except I've changed the target. First, okay, so -e-ma-x. Okay, so now we launch it again, and you will see quite a few things interesting. So we see the exact same exception happening in there, and we see that it did trigger, like the dump, and he wrote, so they crashed them in there, and so this means that now we are ready to review, analyze this memory dump, and see exactly why our application crashed. So, okay, so that is WinDbg preview, so which looks just slightly nicer than the original version. As you can see also in terms of opening things, it's got a lot more options, it's a lot more intuitive in terms of what you can dump, and we want to be here, basically, open a dump file. And yeah, so that's crash. So also when you open a dump file, because the format is always the same, so because that happened to me many times, just check the date and the time, so that you're actually opening the correct dump file, and not something you took like 2 days before, and you say like, I don't understand. So yeah, so that's the good date and that's the good time. So yeah, we can go ahead. So actually, whoops, can I? Oh yeah. Okay. So remember what I said also, the few things that we wanted to check. So we wanted to make sure that it was full memory, so we know, okay, we use the proper switches, and then what I said also, so we wanted to make sure the sim path is configured as expected, which it is. So, in theory, what's interesting since the proc dump, WinDbg is already telling us, oh, this dump file has an exception of interest stored in it. The store exception information can be accessed via .ecexr. So that's a registry. So we won't go and say read the registry ourselves, but it's kind of a confirmation that it's something we want to see. But what we'll do, we'll use what I call the magic command. So that's bang analyze -v, and this command is basically the command that will pretty much fix problems for you. So it takes a bit of time to run because it goes and it tries to analyze the cause of the outage. And this is the same command you can run, let's say, when you have a blue screen of death, and your machine dies and restarts and writes a memory dump. So what you can do, you can just load the memory dump and run this single command, and 99% of the time you'll have a driver name. You either uninstall the driver if you don't need it, or update it, and no more blue screen of death. So, yeah, the output is quite big, as you can see. Good point is we know what we're looking for, because we know what took our process down was, well, a managed exception. So we can just look for the text rather than, skim down and trying to understand. So what we have here is the managed exception address, and up to the right, that's just, an address in the address space of the process. So I'll just copy this one. And so I'll be invoking a command which is PE, so that's short for print exception. And so far, I suppose you're not impressed because, well, that's exactly what we've seen in the console. So you say that, wow, we spent all this time capturing a memory dump. And because of that, all you can show me is basically what I've seen before, and even worse, we've got an offset in here, so not even a line. But see, sometimes WinDbg does help, because you see at the bottom, there are nested exceptions on this thread. Run with -nested for details. So if we repeat the exact same command, but with nested in front of it, we'll get a completely different result. And of course, in here, look at this nested exception. That is an invalid operation exception, and it's got a meaningful troubleshooting information as a message. So that's, you know. And the good point is now that we know exactly, so it was thrown in do some important work. Am I in the right one? Yeah. Is that the one? Yes. And here, you know, you pointed exactly, in our big service, you pointed exactly at the right line where the exception was thrown. So then, you know, you can go and investigate as to why this problem happened. So even though it seems like the context is lost, because it looks like, you know, we only had the outer exception, actually everything is captured. And this is why, you know, you want a full memory dump, because you've got the stack trace, and this means you've got all the stacks, so you can unwrap this, and this is what WinDbg does. It sees what it was executed before. And yeah, in this case, so instead of trying to guess for hours of what could have thrown, we say, well, we know exactly the line that was responsible for this outage.
That was a large method. Would it be pointing us to the line?
Yeah, no, it will point to the line. Yeah, this is true. So at least you will point to the method. If you was a very large method, so you'll have an offset, and if you have the symbols right, yeah, you'll have the line of the exception. So depending, of course, of how the switches you use in the project, when you compile, yeah, it might not point to the line. But if you emitting full symbols, yeah, and remove some optimization, you even get a line number. So that was, you know, the first case. So now let's look at hangs. And again, those happens. So symptoms, you know, well, very slow request. Sometimes they never complete. You know, you got an API, and you've got maybe a front-end application, and one endpoint just doesn't respond. You know, it doesn't time out, it doesn't 500, but it just sits there for minutes and minutes and minutes. And if you do have access to the machine, you'll see that the threads count is increasing. Actually, it is increasing at the same rate that your number of requests at this endpoint. And at some stage, the problem fixes itself. It does fix itself because actually your output dies and it restarts. So you can monitor and probably have a good idea of what's going on if you look at the perf counters, which you don't have access to, always has to. And the interesting part is it might be missed by an instruction. So this, obviously the code is fake, but this is an outage that happened at a customer. And so they had New Relic monitoring this API, and during the outage, our appdex went to 1. We had a perfect appdex, and response time was great, but what New Relic didn't tell us is that our traffic decreased by 95%. So New Relic missed all the requests that were basically faulty, and just saw, like, you know, the one endpoint that was still working, obviously was a lot faster. So you shouldn't always rely blindly on your instrumentation to tell you that something is wrong, because in this case, everything was green. No alert was triggered, except our customers were telling us that obviously it didn't work. And so I'll actually launch this worker, if I can find, yeah, right there, is it? Okay, so we don't need this one anymore. Whoops. Okay. So it's just an ASP.NET Web API, you know, classic API with like controllers and whatnot. Wait, it started on the other screen. Okay, so you can see I'm running IS Express in there. Nothing very unique. So I'm running on the port 5001. And now I will go and, well, I just created a GET request so we can invoke it. So if we go, and so there's just one endpoint, that's the hang endpoint, which, well, yeah, probably gives us a good indication of what will happen. So we wait a bit, but you know, sometimes ASP.NET Web API is a bit slow to start, so well, that's fine. But it looks like, you know, we're waiting more than a bit now. So we just go in there, and okay, so we see IS has seen this request, but you know, you see it hasn't ended. We haven't seen anything logged in there at all. So we just like, maybe it's just the first request. You know, it's just maybe something wrong with it, or so we just. Issue. And it looks like they behave all the same. So the web server itself is still responding. You can see it's processing all the requests, So I've got 4 tabs, got 4 requests started, and we could wait here all night. It will just stay as it is. So now the question is, what's happening? What's wrong with this endpoint? Like, we just deploy this new version, and well, something is not quite right. So first step, we go and get the symbols, so that we can then use them in WinDbg. Just clean this. Delete typing. Yeah. So I guess you're not seeing anything. Okay. So that's okay. So we just care. Obviously, I mean, we could have the other symbols, but they will come down anyway because I think most of them are Microsoft. So we will still have the nice stack traces in there. So we just go pause and local. Okay, so we've done. Wait, have I? Yeah. Oh wait, that's the DLL, isn't it? So yeah, no. Okay, so let's this time. So that's actually the file we want. Yeah, that'll work better this way. Okay, so the next step is so in this case, we don't really care about avoiding an outage because this API has a single endpoint, and as we've seen, this endpoint is just not responding at all. So we'll just go and use proc dump as is without any kind of switch except for the full memory. So what we need, so here is quite interesting, is the process ID. So the same, another tool from sysinternals, which is quite convenient, is a Process Explorer. So let me just, so we'll use, so if we look in here, so maybe I'll just zoom in, but we can see that's IS Express running right there, and this column is the process ID. So that's 8396. Yeah.
Why wouldn't you just attach
In this case, yeah, I could attach, yeah, of course, yeah. Yeah, if the issue is on my machine, yeah, obviously I'll attach a debugger and probably be a lot faster than just, but let's do imagine that this is a production server and obviously, you need to remote attach and all these kind of things. Okay, so say, yeah, 8396, so we'll just go back to the command. Let's see, okay. So you see, like, it took a bit more time here already, because if you look at like the size of the dump, like it was 70 megabytes last time, this one is 490 megabytes, which is quite interesting, knowing that we've got a very simple API, which has one endpoint. So now we are ready to investigate this memory dump, so we just, stop this one. Actually, yeah. So also, see, you've got some nice shortcuts in here, which they didn't have before. So you can just go and clear the window, and we just open the new one. So again, forget to check. So yeah, that's the 29th as today, and good time also that we are looking at the right. So that's a funny bug. It kept the highlight from the previous session. Which is good because like this, I don't even have to highlight it again. So full memory. So again, we're good. The symbols are configured, and you can see like all those dots in here. That is WinDbg loading the symbols, and we don't see any errors. And there's already something that's a bit of an indication. We've got empty wait for multiple objects in there. It's displayed. So I wanted to demo MEX because it's really dedicated it's got lots of function for ASP.NET. So the first thing that I need to do is I need to load it, and you'll see also, wait, I've lost my cursor, it's here. Nope, sorry. Oops, sorry. Okay. Okay. Well, you can't really see, so I'll just enter the command. So you see, I was careful also to load the 64-bit version, x64 of it, and that's why Mex is nice, because it actually tells you when it's loaded, rather than when you load SOS and nothing happens. So Mex tells you, oh, I was loaded, and that's the version you loaded. So in case you wanted to make sure. And it might so happen, and obviously you shouldn't be doing so, but it might so happen that maybe you are computing prime numbers in your API. So maybe actually the CPU is very busy. And yeah, maybe it just takes 5 minutes or 10 minutes to complete. So actually this behavior might be expected. So what we're going to say, well, you know, what are my threads doing? Are they using any CPU time or not? So I see a prefix, that makes, and so the command that's runaway to, and this will give you like your top 10 threads. And what you can see is that our threads are not doing anything at all, like, you know, like really nothing. So we've got 4 requests hanging there, but our top 10 threads are not doing anything, so that doesn't add up. You know, just like, you know, who is running those threads? What are they doing? So maybe, well, we want to look at those threads and say, you know, what are they doing? And this is why also I like Mex, because not only you can list the threads, but it will tell you the actions that are currently executed. So rather than you saying, oh, give me thread 23, give me the stack trace. Give me thread 24, give me the stack trace. Mex will do all of this for you, and on the right side say, oh, those threads are currently executing, you know, this function. Except if I forgot the dot in between. Oh. Is that the right spot?
No.
Yeah, by one error, classic. Okay, so this takes a bit of time because, of course, it goes. So, and we can see a few like nice stuff. So you know, and it does prove also that you know the CLR is not a black box. One of those threads is actually your finalizer. That's the guy that's responsible, you know, for running. And sometimes you want to look at it because, well, you know, bad things can happen also in there. But there is one thing we can notice straight away. There are 4 threads that are not marked as idle, and they are in the same action, and they are waiting on a monitor. So that is slightly suspicious. So we don't know for sure, obviously, those are the 4 threads serving our request. But, you know, we can suspect they are. So what we can do, you know, this is quite convenient. We can highlight.
Just on that, what's it? How does it? It knows about all the weights in CLR, or what made it pick the?
This?
Yeah, what made it show that method?
Because that's the method that's currently executed on the stack in this thread. So that's the method.
No, there's plenty of stacks. There's plenty of methods above it. So what? Like, there's the CLR and then there's BCL below it. What made it pick that?
No, so that's the last one that was executed, not the first one. So obviously there is everything that came before, but this one is basically this thread at some point called a wait, and it's still waiting.
Yeah, but that wait method calls another method, which calls another method.
So you mean, well, obviously it goes into native code. So then I suspect, you know, there is some smart into to decide, so you probably won't tell you, you know, like down to the, you know, the bytecode level and whatever Windows actually run under the hood.
Well, it's not Windows, like, you know, there's just a few. Yeah, I'm guessing that it's got some understanding of what the weights are in CLR, in the front. That's what it's makes.
So if you
also just be focusing on methods in the DLL, the actually the monitoring, ignoring the right spaces.
It's possible. Yeah, it could be that.
Just leave it
Like there's a lot of BCL under that weight just there, so it's surprising that it stopped.
So if you look at, are they the 4 right ones? Yeah. So if you look at those 4s, so which we suspect, so we see here we could just go and look at the managed stack trace to see what actually is happening in there. But first we can illustrate a few more commands that, you know, will help you to troubleshoot these kind of problems. So, and I will load again. Okay. No, that's not the one I wanted to load. So let me just type this command. So we are loading So we are loading SOS again. And because we suspect maybe, maybe one of those threads could be, holding a monitor and the other one trying to acquire it, and maybe, one of those other threads could be, trying to basically acquire the monitor that the first thread has. So there's a command for this, which is actually part of SOS, so you don't even need to go and, and read it. So yeah, that's always happened the first time you run it. Okay, so you run it again, and no results. So it doesn't seem as threads are basically sharing some kind of resources that they're both trying to acquire. So that was something that we had to explore, but that didn't yield anything interesting. But what could help us to correlate those 4 threads with the request is that we could list the requests that are being processed, and we see if the threads ID comes are exactly the same ones. We know that the 4 threads having the issues are the ones that basically are faulty. Okay. So if we deny. Okay. No, that's not the one. So this one comes from MEX. So this is you can see how old this extension is because it starts with ISPX, but he can process. Actually, it's just requests, not ISPX pages. He processes any kind of requests. Okay. And remember the 4th thread ID highlighted? They all match to the request hang. Also, what's interesting, we see the timeout is 110 seconds. If you look at the execution time of those requests, they're all over, and they're still running.
With ASP.NET Core? Does this particular functionality work with ASP.NET Core as well?
Yeah. So some stuff what it won't, such as like sessions and these kind of things. But yeah, lots of the commands will, because actually this one has nothing to do with SPX. So another command which is great, it's just probably the most powerful command from MEX, is the Unix stacks. And what it does is that it looks at all your threads and group them by their stack traces. So especially when we've identified 4 threads which are problematic ones, then you can go and say, okay, lots of stuff are doing things that you kind of expect them to do. So this one is a bit more involved, but this one, see, so all 4 threads are sharing the exact same stack. So that's what we've seen in the past. And so if we look here, obviously we've seen what we've seen before. So the weight, that was the action that was indicated. And well, if you see this part, obviously you've already got a very good idea of what's happening in there. And so the problem is, that's looking at the native stack trace. So all of those, they actually resolve to offsets of our code and also ASP.NET. But yeah, well, I have no idea, and I don't want to go and look at this address. But now we know that just before we entered this line, there was something either in the .NET framework or in our code. So what we can do, we can say, okay, now the thread 36, we can look at what basically at the managed stack trace of the thread 36. So what you can do, you can jump on thread 36 with tilde, and then you say E for execute. So you say, please execute the following command on the thread 36. And what we'll ask for is the managed stack trace. So you can see it's quite different from what we just saw before. And so to reply to your question, maybe the reason you picked that is probably because it's just looking at the managed stack trace, because it looks like we've got a match in here. So it's pretty smart enough to say, okay, this was that wasn't part of the managed stack trace. So if you look, that's the task we had, and that the last line is the only one actually that's in our code, is the hang controller.get. So now that we pinpoint to something, we can go and so have a look at the controller itself. Wait, is that this one? Yeah, let me just fully zoom in. So we just have a controller action here, but it is not an async controller. Okay, it's just a controller. And then he calls, grade class, do something async, and he does something that you might have seen before, and it does, the get awaited would get result. So anybody knows why, that's problematic.
Let's try to get back onto the original thread.
Yeah. So yeah, what happens is obviously here there is the notion of a synchronization context, and in ASP.NET Web API the sync context is a request thread. So obviously the problem is that we are deadlocking ourselves in here, and this is why we should never block in ASP.NET Web API or MVC, because terrible things will happen such as this. So now the question is, if I had the exact same code in ASP.NET Core, would that deadlock? Why not? Yeah, and so we can actually demonstrate this. That is true, so there is no synchronization context in ASP.NET Core. So if I go back, right, and I look at no hang controller, and so this one, see that's part of, so that's part of, what? That's not what I meant to open, okay. So that's part of the, so there is hang API, which is ASP.NET MVC, and there is no hang API, which is ASP.NET Core. I go to .NET Core, so let me just go, okay, so that's the no hang API. Okay, so we did start. Okay, so that's on user screen, so I'll move it here. So the same, you can see it has started. This time we're on the port 5000. And I will call this endpoint. So you can see finally unable to connect, so it's just because IS died. And if we here say, oh, it does look like we deadlock, but actually we don't. So if I could repeat this as many times as I want, it's just because basically there's a delay of 3 seconds in this endpoint. So yeah, we don't deadlock on ASP.NET Core, but that's not a good reason to go and block, because there's still obviously a performance cost to this. So that's the commands we just ran through, and yeah, so there's obviously the reason that there's no synchronization context. So you've got synchronization context in WPF WinForms, obviously ASP.NET Web API, and you don't in console applications or ASP.NET Core. But definitely I want to take you always don't block on async code, because it was just a very honest mistake to make. Someone that just didn't know, that went through the code review, that hit production and then took down like multiple APIs basically. So so then, memory leaks, and something that people are not always aware is that you can, you can leak manage memory. So, or rather you can just allocate a lot of it, more than you intend to. The use case I see quite often is people that use static dictionaries as cache. So there's no eviction, no expirations, and it just grows and grows and grows and grows. And so the symptoms, it's quite simple. The apps get slower. You can see, you triggering more and more GCs. You can see going private bytes. So I won't go into a demo of this one, but the commands you tend to start with, first you use SOS, so dump heap -stat, and what this does is that it will go through all the objects present in your heap, and it will sum them by type and total size. So basically at the bottom of the list, you will have whatever objects as an aggregate is taking the most space, and that's where you want to look at. So if you see some of your things, the problem, strings and byte arrays always tend to be there. So don't start with those, because you might go down some rabbit holes. But if you see, let's say if you see one of your types and it's supposed to be a singleton, or you're supposed to have an instance per request and you're supposed to dispose of it, and you run that many requests, and you've got that many instances, that's definitely something you say, okay, what is keeping this instance alive? So you've got GC root, which will tell you as to why this object is still there. Knowing that having a big memory footprint is not always an issue. Let's say if you do things such as resizing images, or if you generate files and document PDF, lots of the libraries are very smart, so they'll do pooling, they'll do upfront allocation. So what you want to look at is patterns. You want to look at, do I have an increase at every request? For every request I have, 200 kilobytes, and it never gets released. So you can use tools such as Purview and the like, and you can compare memory dumps to see what has been allocated between the two and never being released. And also, and I'll demonstrate this, there is always an out-of-memory exception on the heap, even if it hasn't been thrown. So do you know why? And I'll show you this here. See if I go, so you see, those three, I always have out of memory. Oh, sorry, out of memory exception and execution. Does anybody knows why I always have an out of memory exception?
It's pre-allocated.
Yeah, because if I can't allocate and I'm about to throw an out of memory exception, well, I won't be able to allocate it. So that's why that's one of the first few things that the CLR does when it starts, process is that it pre-allocates an out of memory exception so that should the case come, it can be thrown and you can see it. So if you see that, it might have been thrown, it might not, but just don't think that because it's there, it has been thrown. And those are some of the tools that I use during this talk. So obviously the store version of WinDbg, and you can also get it from the Windows Development Kit. So links to the two extensions. Other tools which are great also debugging and Purview. So those tools are extremely convenient. So PogDump, well, by now it should be quite familiar. You've got also some paid tools. So with ReSharper Ultimate, you've got .memory and .trace. So trace is for CPU profiling. So the good point with .memory is that it can take two screenshots of your heaps and then compare. So let's say you issue request 1, you take a screenshot, issue 2, issue a screenshot, and then you say, okay, what has been allocated between the two? So it can really help you to pinpoint issues faster and probably easier to use also than WinDbg. Competition being Ant Performance Profiler. So I've got also a guide on GitHub, so it links to other resources, books and videos and things on how to get started. So I wanted to thank you for attending this talk. WinDbg is hard, so don't try to go and learn everything in one go. I think it's just important to get started and look at commands one after the other and take baby steps. And soon enough, you'll be surprised, how like many things you can troubleshoot with WinDbg. Thank you. Well, I mean, not full time, but a few years, and yeah, I guess nobody would like to use it full time, but so the first few times I used it, though, I didn't yield anything interesting at all. Like I just didn't understand. But then I started to troubleshoot real production issues, like memory leaks and locks and this kind of stuff, and basically, it's quite a nice experience. We finally see, okay, wow. Something bad happened in production, and I look at them and I was able to pinpoint to a line and tell people, basically, that's what needs to be fixed.
Sorry, so does that mean you have the PDB in the production?
No, so you can have them in production, but that means also in your CI/CD what you do is when you build, and let's say you go and you deploy whatever packages you deploy to production, you can either publish to a private symbol server for your symbols, or you can just put them into a zip files, so that when you've got an outage in production, you can say, okay, these versions are those PDBs, and you can download them on your machine.
Do you drop straight into WinDbg then, or do you actually use something like
Well, I don't think I've ever attached to production. So sometimes if you're lucky, logs are enough, it happens, where they can pinpoint you to issues. I think, it's pretty WinDbg.
So I would have done the second one differently. I would have use Writer, but so I don't know whether Writer has this. But in VS, you can just open the dump, turn on parallel stacks, and it would have given you that information immediately where your unique hangs. It basically gives you a unique view of every stack.
Mm-hmm.
So we'll say there's 4 threads sitting in that, there's 4 threads sitting here, there's 2 over here. And then I would fall back to WinDbg if I couldn't get enough information from that.
Yeah, I think that was a good explanation. So Visual Studio can open memory dumps. Also, it's not as advanced as WinDbg, but it has, it can see a lot, like the stacks and the threads. So some issues, you can definitely troubleshoot just with Visual Studio and go and open memory dump.
Earlier on, you had the exception that got caught, and then you created a new exception and you threw that, and you didn't rethrow it. It was a brand new exception, if I recall correctly, and you still had that original exception in the memory. So what exactly, at what point does that old exception leave memory? Like, is that going to keep track of every single exception that got thrown and caught? Like, at what point, like, what is it exactly to keep track of?
So performance counters obviously will follow and count and aggregate, but it won't keep everything in memory. So things get disposed. Obviously, the garbage collector is running, and in this case, it's because we captured the memory dump when the application was terminating, but it wasn't terminated. I was still alive, so the exception was actually still, on the stack. It was still available. But yeah, let's say if you was ASP.NET and you had request 1, an exception being thrown, and then request 2, and you capture the dump on request 2, you won't see, the exception from request 1 anymore if it's gone out of the, it's been processed and it's been collected already.
Thanks, Gabriel. Any more questions?